preview for quiz number 6. All right. I'll get there. These first 3, I'm going to definitely do all of them. So a basketball player is standing outside on a sunny day. He is exactly 6 feet tall. I'm not even going to try my drawing skills today. I'm just going to be very plain. If he casts a 7.8-foot shadow, that shadow is on the ground. Don't make the 7.8 your hypotenuse. What is the angle of elevation of the sun? Because again, remember, when you're looking for elevation, think of it like, you're looking up. Depression, you're looking down. Elevation, you're looking up. So, which trig function would I be using? Tangent, because it's opposite and adjacent. And since I'm looking for an angle, remember, I'm going to take that fraction, and I can either put it in its fractional form, like it is currently. And I need to get a better calculator. You're like, Hardy, why are you putting all this weird stuff? Because I want a good calculator. That's better. Okay. So, again, make sure your mode is in the correct place, that somebody hasn't decided it'd be fun to put things into radians.
You tell them not to do it, they do it anyway.
Well, I don't tell certain groups not to, because if I did tell them not to, they specifically would. So, that's where that comes from, okay? If I don't do the -1 and I get some little tiny decimal, hopefully you'd look at that and say, well, that doesn't make much sense for an angle. It should be a bigger number. Oh, yeah, I need to do the inverse, okay? So that's where number 1 would come from. Now, number 2. This is a little more interesting. Okay, from the top of the school, you spot your car at an angle of depression of 41 degrees. If your eyes are exactly 78 meters up, how far away is your car from you? Now, here's where this gets a little more interesting, okay? Angles of depression. Let me get this out here a little bit. What you're actually doing is you're looking at your angle and it's out in this area. And you're like, well, how do I do that then? Well, there's a couple of ways you can tackle this. You can either go old school geometry and say, ooh, parallel lines, 41 degrees. Or some of you look at this and say, well, this is 90, so if this is 90, this would have to be 49, okay? I can use either of those to get my answer. If some of you came down and said, I'm going to use the 41, you'd have opposite over adjacent. So you would set it up as the tangent of 41 is opposite over adjacent, and we'd solve that. Now I'm going to split it here a bit, because if some of you said, well, I'm going to use the 49, because I can remember this 90-degree thing. In your case, you would have opposite over adjacent this way. So you'd have the tangent of 49 equals opposite over adjacent. How you punch these in the calculator would be very different, though. If you were using the 49, I'd multiply by 78, and my x would be 78 times the tangent of 49. That'd get my answer. Be careful if you're over here. This is the type of question I talked about back in the last quiz that got some of you. Your setup here was perfect, but then you wanted to multiply, and you can't. Because if you multiply here, you'd have x times the tangent of 41 equals 78. So to get your x value, you would end up with 78 divided by the tangent of 41. But what you'll find is, either way, so if I do 78 divided by the tangent of 41, or I do 78 times the tangent of 49, I get the same thing. So no matter which way you go, you get to the right answer. So just be cautious when you're setting those up, because whether the word is angle of depression or angle of elevation, it can change up some things on you a bit. So scooch up a little here towards 3. The sides of a parallelogram, given, have lengths of 18 and 27 feet. Okay. And one angle is 38 degrees. Now again, look at the angles. The one that looks acute would be where your 38 degrees would be. And I know the opposites are the same, so I'm just going to put it in both places. Find the length of the longer diagonal. The longer diagonal always will go through your acute angles. And we've been in a situation like this before. Well, I just cut the 38-degree angles. That means 19 on each side? No. I need to know what this is to make this a little bit easier to work with. How do I figure that out? Huh? Consecutive angles of a parallelogram are supplementary. What does that mean? They equal 180. So if I subtract the 138, excuse me, the 38 from my 180, okay, I get 142 degrees, which lets me know that angle. It says, label appropriately and use the law of cosines. Okay, so my x squared is going to be the sum of the squares of my two sides, so 18 and 27, minus 2 times their product times the cosine of my angle. And again, this is the version of it when I have the angle in two sides that I can plug directly into the calculator. It's the one when I have 3 sides that I have to be a little bit careful. So let me come over here, and as long as I'm cautious and type this in exactly, I should be in good shape. As long as there's one other thing that I'm careful about. And we just are going to make sure, yes, 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 yes. And yeah, I got to square root this. Or that wouldn't make a whole lot of sense for that diagonal to be 1818 when my other sides are so short. So 42.6. Okay, that's sensible. So we can kind of roll that way. That's kind of the old stuff. Now we get into the newer stuff. Draw the following angles in standard position. Okay. 265 degrees. Let's see here. 90, 180. Okay, 270 is over here. So I know I'm going along this way because I go counterclockwise when I'm doing this. Now here, I need another, how many more degrees do I need here? I'm at 180 as of right here. I need to get to 265. 85. So I'm like, okay, let's see here. I've got to scooch over a little bit because I'm not even going to fit. All right. So I need another 85. Now here, some of you are like, now do I go this way or do I go this way? Well, actually, you can go either way and get to where you want to be, but I would suggest you always are lining up your baseline with the last axis that you're using. So since 180 is my last one I'm using before I get to my answer, I'm going to use this axis, and from there I'm going to count my 85, which is about right here. It's going to be a really sharp angle. Use my new handy dandy ruler that comes about it, and I can finish it. Now some of you may say, well, could I do it the other direction? I mean, if I had it this way, you know, what would I do? Well, if I'm coming from this point of view, I only want this 5 degrees. That's different here. So I'd have my point and I'd draw my line this way. So I really suggest, though, whichever the last axis you're using before you get to your angle measure, that you use that. What do I do if it's in pi? What do I do if it's in radians already? Put it in degrees. 180 over pi. So it's okay if we have something in radians and turn it into something we like dealing with a little bit better. Okay, so we're looking at 315 degrees. So we're going clockwise again because we're positive. So 90, 180, 270. I need another 45, and since the y-axis is the last one I was working with, I'll get my extra 45 from there, and I'm ready to go. So what if we switch it then and it becomes a negative angle? What changes?
The direction.
Yeah, the direction. We're going to go clockwise now. So now, as I start working around, now I'm going clockwise. So 90, 180, 270. But I need another 10 degrees, and the y-axis is the last axis I made contact with. So here's my 10. We'll get that lined up with the origin and finish that off. Yeah. Yep, I got more. I was going to say, I've got a stack of them over here still, so if any of you are in needs of them, I've got you set. And then one last time, get that into degrees. And once we're in degrees, remembering that I'm going counterclock, I'm like, okay, so, I'm going clockwise. Holy cow, Hardy. So 90, I need 30 more. So I'm like, okay, there's my 30. And I'm ready to roll. So get those initial 90s done, and then you just use your protractor to figure out that extra little chunk at the end. Convert to degrees or radians. I would hope this one's not a bad one for you. If I want to go to radians, I do pi over 180. And I simplify this. Simplifying the fraction part down as far as I can. And we just got done doing a couple of the radian ones, so I'll kind of do one of these. Okay, C5 or 7 if you need help in figuring out how to turn those into degrees. We're just going to multiply by 180 over pi to get rid of pi. So again, nothing going on too terribly awful. And some of you are going to take a big breath of relief when you turn this over to the back. There are no logarithms. Okay. So, okay, one positive and one negative coterminal angle for each. Okay, remember, positive means we're just adding 360 degrees. Negative means we're subtracting 360. But remember, when you're doing these, so let's look at 13 and 14. If you add 360 to get your positive, okay, that's not a big deal. You even could subtract 360 from that one and still be a positive coterminal angle. Okay, either one would work. But when you get to negative, now here's where you've got to think a little bit. You're like, okay, 780 minus 360 is 420. If you circle that as your answer, because again, it's a negative coterminal angle. That's not negative. Well, okay, so I'll subtract 360 again. 60. Can I circle it?
No.
Nope. It's not negative yet. Minus 360. Negative 300. Now I'm ready to circle it. Okay. So one has to be positive, one has to be negative, even if you have to repeat the process more than once. Now, one thing we always like to say, except when we're drawing angles, is if the problem starts in radians, it needs to finish in radians. So, when I get to here, I can't just turn this into degrees and then work through and say, woo, yeah, no. So, negative 3 pi over 4. If I'm adding or subtracting 360, what's the equivalent in pi? 2 pi, because each pi is worth 180. So if I want to add or subtract 2 pi here, my 360 degrees, if 2 pi over 1 is 360, and now it's over 4, I have to multiply the numerator by the same thing. 1 times 4 gets me to 4. 2 pi times 4 is 8 pi. So for my positive, I have 3 pi over 4 plus 8 pi over 4. I have to have a common denominator. Negative 3 plus 8 is 5 pi over 4. That's positive. And then I just do the same thing for my negative. Negative 3 pi over 4 minus 8 pi over 4 would be negative 11 pi over 4. Okay, so if it starts in radians, we need it to end that way.
How did you get 8 pi again?
Because basically what I'm doing on these is I'm saying if I have 2 pi and I turn that into a fraction, I put it over 1. And I need it to be something over 4, so it has a common denominator. So since I multiply 1 times 4 to get to here, yep, I'm just doing the same thing up in the numerator for that. Sure. Now name the reference angle for the following. Okay, remember. Okay, there's a couple of ways you can do this. How far is it back to the x-axis if you were thinking of it as a picture? Or you can just look at it and if you remember, oh yeah, this is a thing where I'm minusing or plussing 180 trying to figure this out. So like if I were doing 15, okay, one thing I could remember is, well, I can't subtract 360 because, well, that's bigger than this. So there's one of two ways. You could either go, oh, I just minus 180 from it. Oh, it's 15 degrees. Or if you're like, there's too many other things to be thinking about. This isn't going to work that way. You could make yourself a quick little sketch. Now, it doesn't have to be perfect with the protractor. You'd be like 90, 180. Well, if this is 180, how much more is it going to take for me to get to my terminal side? 195 minus 180, oh, 15 more degrees and I'm there. Same answer. So you can do it with a picture, or you can do it just kind of thinking about it. Because no matter which way you go, okay, 90, and I would need another 20 degrees here, but that's not my reference angle. The reference angle is how far is it now to get back to the x-axis, which is another 70. And you're like, oh, 180 minus 110 is 70. Right. If you want to keep using 180 and 360, as long as it's bigger than this, you can keep doing that. Here, 360 is bigger than 348. I could do 360 minus 348, get 12. Or I could draw the picture of a 348 degree angle and find out, oh, it takes 12 degrees to get back to the x-axis. Okay. Now the negatives might be a little tricky. Might have to draw these. Okay, let's see. Negative 90, negative 180. I'm not quite going to get to negative 270 here. How close am I going to get? Okay, I'm within 5 degrees, but, okay, the 5 degrees that I see right here is to get to the y-axis.
95.
If it's 90 degrees for the quadrant, and this is 5 degrees away, what do I have left?
95.
85.
80.
Right, it's always how far am I from the x-axis. Right, but you're going to the closest x-axis. I'll put it that way.
So it would be 360
That's the part why I don't like doing that one with this one, because if you do, right, because you'd be doing, if you try doing 360 minus 265, that's like 625. And I didn't know if some of you would see that right away. So if you treated that like it was regular 265, it would be the same. It would be the same way. And then again, reference angles. Turn it into degrees first. 150. Okay, so let's try to do this up in our heads here. If it's 150 degrees and I'm looking for the reference angle, okay, it'd be 30 degrees, but you're like, why is there always got to be a but to this? It started in radians. It needs to finish in radians. Okay. So like if this were a question on the quiz and you left it as pi, left it as degrees, I'd ding you for a half. Yep, it's going to be pi over 6.
You can't just take negative 270 and subtract negative 265.
No, because if we were back on 18, it was 270. 270 is a y-axis value. And I've got to get to x. So it's always, whenever I'm doing that, it's always 180 or 360 that I'm using. Because those are my values on the x-axis. Oh. 20. If the minute hand of a clock is 7.5 inches long, radius, how far did the end of the minute hand travel from 9 a.m. to 11 a.m.? Okay, the minute hand. So let's see here. We know our radius here is 7.5. How many degrees did the minute hand go in 2 hours? How far around does the minute hand of a clock go in an hour? 360. So how far it go in 2 hours? 720 degrees. But my angle measure, whenever we're using the formula, has to be in radians. Ooh. So it will be. So when I turn this back into radians, because that's what I do, I get 720 pi over 180, which is 4 pi. So to find my arc length, 7.5 times 4 pi, okay, it traveled 30 pi inches. And if some of you wanted to plug the decimal back in for that, at that point you could. So basically, when we're doing these, Oh yeah, I'm gonna finish. This is gonna be great. So 21, a puppy is chained to a post along the side of the house. The chain's 8 feet long. Assuming he can rotate 180 degrees from one side of the house to the other, how much of an area of lawn can he fertilize? Okay. So, this chain is 8 feet long. Radius. He can rotate 180 degrees, but I need that in pi speak. What's 180 degrees in pi speak? Pi. Okay. So my area is 1/2 my radius squared times pi. 64 pi over 2 if I multiply across, which is 32 pi, or if I feel like actually knowing this, because I find this kind of interesting now that I have a dog, 32 pi, 100.5 square feet of dog poo. But if you left it as 32 pi, I wouldn't jump up and down and yell.
Is X adjacent?
Yes. I will hit that one in just a second. I'm actually going to go to 23 first and come back to 22. Okay. You are told that the tangent of an angle is positive. Okay. That tells me it's in one of two places. It's in the all quadrant or the tangent quadrant. Where's the terminal side of the angle? Are we limited to just one quadrant?
No.
Okay, this graph, this little picture, that actually answers it for me. Quadrant 1. Even if you just did that, that's an explanation. Because they're all in quadrant 1. The tangent is in quadrant 3, so as long as you tell me quadrant 1 and quadrant 3 and why with this or something like that, that's good. So don't think you got to write like a 5-paragraph essay.
What do we have to write?
Yes.
What do we?
This, or you could write quadrant 1 is all trig functions, and quadrant 3 is where trig functions are positive. Tangent functions are positive. You could write it that way if you wanted to write instead of drawing.
Are we turning this in?
I can't see that far.
Reviews are becoming for prep purposes only
So no.
in here. Because I figure if you don't want to mess up the quizzes and stuff, you're going to do these. Now, I could be silly, but...
Hey.
So here, I'll do it both ways because I have a minute and a half. I have time. Okay, adjacent and opposite.
Oh, I didn't put you on that.
My hypotenuse would be the sum of the squares. So 9 and 4 is the square root of 13, which is my hypotenuse. So my sine, and I could draw the picture too. It's opposite over hypotenuse. I'll come back to fixing that in a minute. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, but since they're both negative, it'll be positive. If I do my square root of 13 business for my sine and my cosine, -2 square root of 13 over 13, this would be -3 square root of 13 over 13. And then again, when you go to flip, go back to the original. Square root of 13 over 2 is okay. You can have the radical in the numerator, just not in the denominator. Over 3 and 3/2. Okay. So it's looking as though,
I have a question.
1 second and then I will answer it. It looks as though the review for our mastery manager, universal screener, okay, that has become your regular homework. I will have a video for it online, I'll even have a key for it online for you to check things. Because what you've got there is extra credit on a quiz on the line if you can beat the last one. And if we can be number 1, I'll even tack more into it. So work on that over the weekend. We'll do some questions on that Monday before the quiz.